Hello, welcome. This is your lesson on graphing lines, lesson 2.2. This is a standard Algebra 1, Algebra 2 lesson on lines. You've probably had it a few times, so I'm going to go relatively quickly. This should be a review for everybody. Once again, pause the video if you need a moment to write these formulas down and I'm going too fast. The slope formula, y2 minus y1 over x2 minus x1. Sometimes it's called delta y over delta x. That's the delta or the change in, and then also when we're graphing we use the term rise over run. For point slope formula, y minus y1 equals m times x minus x1. Now remember, the x1s and y1s are the points as I listed below here. The m is the slope, so I guess I could put that in my slope formula up here, that m is also slope. And then the x and y are your variables. For slope-intercept form, if you want to label everything, the x and y are your variables. The b is the y-intercept, where the graph crosses the y-axis. And the m is, of course, the slope again. And then for standard form, x and y are your variables. And these a, b, and c are just coefficients, we call them. They're just other numbers that end up going into the formula. They don't really mean anything per se. They're just numbers that help you easily find the x and y intercept. So away we go. What I'm going to do is I'm going to only do one problem, but I'm going to do it multiple ways. So this question here, I'm supposed to write the equation of this line in all three forms, and then I'm going to graph it on my last slide. So the first form, I'm going to go back, I'm going to do this problem in point slope form. So once again, here is the point slope formula. And since I have 2 points here, point 1 and point 2, I could actually use these points to figure out my slope and figure out my entire equation. So what I'm going to do is I'm going to start with the slope formula, and that is y2 minus y1 over x2 minus x1. And I'll just plug and chug for this problem. So the y2, I'll just pick the 4, as that's the second point listed, minus 3 all over negative 1 minus 2. Simplify to get my slope. So 4 minus 3 is 1, negative 1 minus 2 is 3, but it's negative, so I have negative 1/3 as my slope. Now, since this formula is called point and slope, guess what? You have a slope and you have a point. That's what indicates which formula you use. So I'm going to take this negative 1/3 and substitute it in for m, my slope, and I always have my standard x, I always have my standard y. Those are the variables in the function. And then I could pick either one of these points. Now I'm going to pick the first one because I'm not a big fan of negatives, so I try to pick the one that doesn't have negatives or has a little easier numbers to work with. So I'm going to substitute the 3 in for y1, and I'm going to substitute the 2 in for x1. You have to pick the same x and y from the same point, however. And then I do a little simplification. Y minus 3 equals negative 1/3 times x minus, now I forgot here, I need to distribute this. So what I'm going to do is I'm going to get my eraser out here. I'm going to erase this baby. And I am then going to distribute the 1/3 into the x and distribute the 1/3 into the minus 2. Now there's two negatives there, so it becomes a positive. So 1/3 times 2 is 2/3. That's the fraction objective from Unit 1. And I'm going to solve for y. So I'm going to add 3 to get the y to the other side. So I end up getting, canceling these, y equals negative 1/3 x, and then 2/3 plus 3. 3 and 2/3 is perfectly acceptable. You could also do 11/3. That's the same thing as 3 and 2/3, but I'm okay with that. So I'm going to take a moment here and I'm going to show you what I have. This first box that I'm doing right now, this one right here, using my lightsaber again, this is point slope form. So if the directions were to place your equation in point slope form, I'd be done. Now if your directions are to place your equation in a slope intercept form, this stuff right here is a little bit of a rearranging using your algebra, using your techniques from Unit 1 to get the y by itself, because y alone is your slope intercept form. So now I'm going to use a different color here, and I'm going to highlight my slope. That's my slope. And then I'm going to highlight my intercept. That's my intercept. So from our formula on the previous page, y equals mx plus b, you now have slope-intercept form. The last example is standard form. Y equals ax plus by equals c. From the last slide, I had y equals negative 1/3 x plus 3 2/3. Actually, it was a minus. So what I need to do now is I need to get the x and y on the same side. That's what my formula indicates. So if you look at the problem I have the line formula, but I don't quite have it in this form. So I need to bring both of these two guys to the same side. So what I'm going to do is I'm going to bring the 1/3 x from the right side over to the left by adding. Why add? Because of course it's minus or negative. So then I get negative 3 2/3 equals, now the x normally comes first in standard form, so I'm going to write that as the 1/3 x plus y. Now this is okay in standard form. I'm perfectly acceptable with this because you have your a, b, and your c. However, I'm not a big fan of fractions, so if I'd like to eliminate those fractions, I can do that. I'm just going to change this 3 2/3. 3 times 3 is 9 plus 2 is 11, negative 11/3. If you look here, everything has a denominator of 3, so I'm going to multiply everything by 3. My final answer is going to be 1/3 and 3 as I distribute this in, cancels, and I get 1x. I'm just going to use a wiggly line here to separate this. 3 times y is 3y. And 3 and the 11/3 cancel, and you get negative 11. This is standard form. So when you're asked that, that's all you have to do. Now, for my last slide, I'm going to graph this, and I am going to go to this part right here, and I'm going to recopy this on my last slide. Y equals negative 1/3 x minus 3 2. Now, graphing can be tricky, but especially when you have fractions like this. So there's lots of ways to do this. Now, this is the y-intercept according to our y equals mx plus b. So I'm going to use the y-axis, which is this axis here, and I'm going to go down to negative 3, negative 1, negative 2, negative 3. I don't know if you can see those little marks there, but negative 3 2/3 is right about here. I'm going to make that a little bigger. So 3 2/3 is right about there. It's a little bit, it's more than 3, but it's definitely less than 4. And then for the slope, remember we did rise over run, so I'm going to rise 1, run 3. However, it's negative, so instead of rising 1, I'm going to fall 1. So using a different color so you can kind of see what I'm doing, this is 1 unit, and then I'm going to walk 3 units. 1, 2, 3. So where my little mark ended up there, that is the location of my final point, and I connect the dots. Now, of course, you could just graph the original points, and that's all you needed to do, but I wanted to show you how to graph a function in slope-intercept form. Thanks for listening.